Hello all, welcome to my channel. As we had discussed in our last video, we were saying few alternatives to Red. Means we were saying how we can use in-memory or key value stores for certain use cases that we have, and Redis was one of the major key value stores, which stores data in memory. And to in this blog, this is a part two of that series where we will see which are the options that we have if we want to have key value stores and we see that Redis is costing too much of money. What are other cheaper options that we can look at, which can solve the problem? So let's get started. In this video, we will see open source alternatives to Redis. So as we know, there were a lot of things which Redis has good in a sense. It offers an high-speed data access. Data processing is also there and supports very advanced data structures as well. Uh, it has certain downsides, like it at times in heavier loads it might start to slow down. So that is one challenge of this. But in general, it is very fast and uh, very performant as well. But there are certain cases where we might want to have an alternative to this. One is the licensing. So Redis has changed the license after few times back, and that's when people started to worry about whether Redis will be available in cloud platforms or not. And that's when major cloud providers created a new fork of Redis, and they created the project is called Valky. So Valky is a Linux Foundation backed open source fork of Redis, supports has a compatible solution, which is the APIs are compatible to Redis OSS, but it was only having compatibility till .x. Newer versions will not have that compatibility, and this is available in AWS and major cloud providers as an alternative to Redis. It has certain improvements, like it supports multi-threading for input and output command execution. It has enhanced I/O multi-threading. For example, it can serve 1.919 or 1.2 million requests per second with new I/O threading that is up there. So the benchmark says that it is almost at par with the enterprise grade Redis read and write performance. And also it has also improved the multi-core utilization and asynchronous threading over Redis. So it has done a lot of improvements over the Redis, which was open source Redis, and it has now feature parity equivalent to uh, the enterprise grade Redis, which we used to get when we had a license from Redis company. Not fully, but yes, it matches most of the things which are present in there. So this can be a very good alternative if we are looking for an open source version of Redis to be available to our system. Then we have KeyDB. Again, this was built at Snap. So Snap company built this, and it was positioned initially as a multi-threaded fork of Redis, and it has the capability benchmarking, like it can do 1 million operations per second on a single node. So which is very high number compared to what Redis offers. And KDB was designed for extreme scale and low latency access and high throughput. So it does provide all the features, like it has fewer bottlenecks compared to the open source Redis. And it comes out of two standard features. One is active replica and multi-master mode. So we can have, so Redis has a single leader system, right? In case of KDB, we can have multi-master. Plus, we can also have active replica. So if one goes down, the other one becomes the active and serves the request. So that is there. It is also supports Flash, KDB Flash built on RocksDB. So if the memory is getting filled, it will spill on disk. So that again is something which makes it a more scalable solution. And the compatibility wise, it is mostly Redis compatible. The future of this is something which is not sure, because a lot of engineers who are working with KDB now contribute to the Velki project, which is an open source fork of Redis. So it might, all the features that we have with KDB might get merged with Valky. But apart from this, it is already production ready. It is already there in production at Verizon, Netlify, and the Trade Desk plus Snap, which built it. Another good alternative to Redis is Dragonfly. So it has a good buzz around it, like a lot of talks were given by many folks that okay, how it improves over Redis's solution and how it achieves a lower cost compared to what Redis provides. So it is a managed as a solution. It is not an open source solution that is out there. So managed one is fully managed cloud product and is available as a source available. Community edition is there, but to make it work in production, we need a license. It it does a shared nothing architecture that enables throughput and multi-threading at a higher level. So this is another alternative that we can look at. There is a project called SkyTable, which is not that much known, and the reason for that is there is no major vendor which is supporting this. But if your engineering team had certain bandwidth and they can look at the code and do maintain, so this is a good uh, solution as an in-memory uh, key value store. It is written in Rust. It gives around half a million, more than half a million ops per second in read and write. It is still evolving, very smaller community, but it was earlier known as database DB. Now it is open source, so uh, discussion and documentation are very limited. As I mentioned, that there is no much of vendor support. Hence, but it is very promising. The numbers look interesting. Compared to what a single node performs for Redis. Apache KVRocks, again, this is a key value store that is an Apache project, and it gives a distributed key value database. It has the compatibility with Redis protocol, supports common Redis data types as well. It uses RocksDB as its storage engine, but has an in-memory cache as well. Uh, so it is something which can be used in place of Redis if we have slightly relaxed latency numbers that we can abort. And because this uses disk, it can scale a very large uh, scale as well. And it can scale to a very larger sizes of databases. It is already in production at Baidu, Trip.com, DataVisor, Opera. And this has Redis compatibility as well. We can use Redis CLI to interact with this. So this is another project which is out there. Hazelcast is an open source in-memory grid, data grid that is based on Java, and it can be scaled horizontally to meet growing application needs. And it provides high ability and replication, failover, everything. It is it is almost an enterprise product. It has a community edition which is open source, but if you want production systems, you will have to take a license from Hazelcast, and it has full support in a sense that you get full-fledged product which can do in-memory key value store for you. The only challenge with this is if you are coming from a Redis ecosystem, there is no compatibility between Redis API, so you will have to rewrite your application to leverage Hazelcast. But it is being used in large companies as well. Pegasystems, which is a large BPM solution, uses Hazelcast as their in-memory cache grid. There are some other options as well, like Garnet, Redict, Redka, and PKVDB. These are, for example, this one, PKVDB is a disk-based Redis compatible database. So instead of using everything in memory, it uses disk. So if you have scale requirement with slightly less latency sensitive applications, PKVDB can be in a good approach, good option. Apache Ignite is another project which is there. There are others which are not either they are not that much of an activity and their GitHub repo doesn't have that much of an activity or not much traction. So that is there. Garnet is something which was recently open sourced by Microsoft. So that is again something we should be keeping our eye open to see where they go with the solution that we have. So yeah, these were the things that we can use. For example, Velkey, SkyTable, KVRocks, Dragonfly, KeyDB as an alternative to Redis. So we don't have to stick to Redis itself. There are other solutions as well. And which is also from a design point of view, knowing these things that, okay, how different solutions are trying to improve upon Redis will help us in creating a greater sense of what the solution that we are looking for should look like. So that's where this blog series ends for the key value store. We will see how it goes further. Uh, if you like this series, do share and spread the word. Have a nice day. Bye.